Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.113. While solving this problem, we will be using Kirchoff's current law. This law states that sum of all entering currents on a node is always equal to sum of all leaving currents from that node. According to this law, cumulative current on a node inside an electrical network is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.113. Read the scenario. Find the value of current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this 2 ohm resistance branch labeled as I0. So without wasting time, let's proceed towards the solution. This network includes two nodes only. One is reference or ground node, and other node will be used to apply Kirchoff's current law. All entering currents or leaving currents on this node will be taken with the reference of this node. Now write Kirchoff's current law equation for this particular node. On this node, two currents are entering. One is 6 ampere and other one is 2ix. While two currents are leaving, one is I0 and other one is Ix. Now, in order to further solve this problem, we have to find the equations of current I0 and Ix. Equation of current I0 will be voltage across this 2 ohm resistance, that is V0, divided by the value of resistance 2 ohm. Similarly, current Ix will be calculated using this equation. Ix is equal to V0 divided by 1 ohm. Here V0 voltage will be appearing across 1 ohm resistance because of parallel connection. Now place the values of current I0 and Ix inside this equation for further solution of the problem. Current Ix is replaced with V0 divided by 1 ohm and current I0 is replaced with V0 divided by 2 ohm. Open these brackets and take the product of 2 and V0 divided by 1 ohm. The equation will become 6 ampere plus 2V0 minus V0 divided by 2 ohm minus V0 equal to 0. V0 divided by 1 ohm will result V0 only. Same case will be with this equation. Now, in order to further simplify this equation, we will multiply this equation with 2 on both sides to cancel out this 2 ohm in denominator. So the product of 2 and 6 will become 12. Product of 2 and 2V0 will become 4V0. This 2 ohm in denominator will be cancelled out with the product of 2 and only V0 will left. And at the end, product of 2 and V0 will become 2V0. Now inside this equation only one variable is left, so we will solve this equation to calculate the value of V0. Add minus 2V0 and minus V0, it will become minus 3V0. Subtract 3V0 from 4V0, it will become only V0, and place this 12 on the other hand side of equal. So the equation will become V0 equal to minus 12 volt. We have calculated the value of voltage V0. Now we can calculate the value of current I0 by placing the value of voltage inside this equation. So the value of current I0 will be equal to minus 12 volt divided by 2 ohm. Current I0 will become minus 6 ampere. Here minus sign is indicating that the actual direction of current I0 is opposite to the direction given in the scenario. So this was exercise problem number 2.113. Thank you. See you again in next video.